Hey everyone, so today's lesson is lesson 62, logarithmic word problems. So please turn to the page that says lesson 62 so we can get started on this. Now throughout this lesson, because I recorded it, I would like you to please follow me as I go through the lesson and also pause the video whenever I say to pause it. And that's because I want you to try to attempt problems on your own with your partner or with someone next to you or by yourself and see if you can solve it without my help. And then if you do need my help, press play. And I'll go throughout the whole problem inside this video. So basically today's lesson is based on how to solve word problems that need to utilize logs. And this is going to happen when you have a variable in the exponent. You already know how to solve this. You learned how to solve it in lesson, I believe, 59 and 60. And now you're just applying it to word problems. So what I would like you to do right now is read through the do now. Attempt it on your own for 2 to 3 minutes, and then when you are ready, start the video up again. So give it your best shot. Alright, so hopefully you pause the video and work through the problem, but right now I'm going to work through it with you. So the first thing I'm going to do is read through the problem. It says the population of Laughlin, Nevada is modeled by the function this, where t is the number of years since 1990. And they're asking, in what year will the population be fewer than 50 people? Now, first of all, you should recognize this formula. It's very similar to AB to the X. A is your initial, and B is your growth or decay factor. Now, because B is less than 1, I already know that I am decaying. So I know that my population is decreasing. Now, to solve this problem, you're going to take your formula here, and you're going to set it less than 50 because I want to know how long it's going to take in time for this population to be fewer than 50 people. So the first thing you should do in order to solve this algebraically, because that is what they would like us to do, is isolate the base in the exponent. So I'm going to divide by 1,736. And if I divide those out, I'm going to get 0.0288. Okay, so hopefully I did that right. And when you solve for this now, you're going to utilize logs. And the reason why we're going to use logs is because if you realize your exponent here has our variable and I want to bring him down. And you could use a natural log or a common log, whatever you prefer. I'm going to use ln because that's usually what I prefer to use. But again, you can use log. It does not matter. You'll obtain the same answer. So if I put an ln here, I'm going to bring down the t. So take the cowboy off the horse. Okay, and when I divide by this to isolate my t value, you should get t equals 12.68. Now here's the deal. You want to be fewer than 50 people. So although t equals 12.68 is a good number, you need to round to the nearest year. And they want to know in what year. I know I started in 1990, so I need to figure out, am I going to add 12 or am I going to add 13? If you add 12, the problem is you're going to be still over 50 people. And if you can actually type in your calculator into the original function, you will realize that it will not give you less than 50 people. So if you plug in 13 for t, you will realize that this formula will give you something less than 50 people. So I'm going to add 13 years to 1990, and I know that I'm going to be less than 50 people in the year of 2003. So that is my answer. Okay, so question 1 on your lesson states, suppose you receive an inheritance of $5,000. This is what you're starting with. This is your initial value. So we would name this A. And it's invested at 5% interest, which means that your R is 0.05, and it's compounded annually. And that means that your N is 1. And the nice thing about this problem is that they actually give you the formula, so you don't have to solve for it. But if you realize they say compounded, so they're probably using A equals P 1 plus R over N to the NT. N is 1, so basically you don't see that in your formula the way it is. So this is just where this formula comes from. They replace P with 5,000, they put R in for 0.05, they divide it by 1, and you will obtain this if you wanted to find it on your own. Now they also say that X is the number of years your money is invested, and A of X represents the amount of money you have in the end. And they're asking you, how long will it take for you to double? And first we're going to use the graphic method, which means that you need your calculator. So if you need to go get your calculator, please pause the video and grab it at wherever it is and definitely set it up to be using it for this problem. Okay, so first off, your formula is 5,000, 1.05 to the X. Okay, and you want your money to double. So that means that your money is going to become $10,000. Okay, we're definitely increasing our value. Now, usually when I would teach this to you, I would say 5,000 divided by this to isolate the base and the exponent. And these would cancel, and you end up with 1.05 to the X equals 2. And we would make this Y1 and make this Y2 and see where they intersect. What I would like to do instead is I would like to not isolate the base and the exponent because I want to utilize your window a little bit more. So instead of doing that, I'm going to make this whole entire thing Y1 and this whole entire thing Y2 and use my window a little bit more to see where they intersect. So if we're going to use our window, please make this, first of all, type these two things into your Y1 and Y2 and change your X min to -10 and your X max to 10. And your X scale, I'm going to make 5. What X scaling means is that when you count the number line of the X axis, it's going by 5s. And that's going to make us see the picture much clearer and easier to see the intersection. I'm going to make my Y min 2,000. And the reason why I chose that is because my initial is 5,000. So 2,000 is probably a pretty good area to make my Y min. And I'm going to change my Y max to 12,000. And scale it by 100, which means that every single place on the y-axis is by 100. So then you should obtain a graph that sort of looks like this. Now, if you remember to do this and find the intersection, you're going to press second trace, intersect, enter 3 times, and you should obtain an intersection of x equals 14.2 years. This is how you do it graphically. If you had some trouble graphing this, please pause the video and take a moment to graph it in your calculator and do all the steps that I did and make sure you obtain 14.2 years. If you are fine with that, continue with the video. Okay, so Part B asks you to use an algebraic method to solve what you found in Part A. So basically we're trying to use algebra in order to obtain an x value of 4.2 years. So the first thing you're going to do is set the desired amount a of x equal to what you want it to be. Now this should be a of x. And we want our money to double, so I'm going to set a of x to 10,000. Okay, the next thing you want to do is isolate the base and the exponent, and this should be very familiar because you do know how to solve exponential equations. This becomes 2. And the next thing you want to do is take the log of each side. Now you could use log, you could use ln. In this case, I will use log, so I'm going to put a log in front of the 2 and a log in front of the 1.05. And what that allows us to do is bring down the exponent. And that is actually step 4. Use the power rule to simplify the equation. That's bringing the cowboy off the horse. Now in order to solve for x, I'm going to divide by log of 1.05 to get x alone. And again, please, when you type this into your calculator, make sure you put these things in parentheses. And you're going to obtain an x value of 14.2 years. So there you have it. You can do this both graphically and algebraically now. Okay, number 2. It says if the population of African lions is decreasing at a rate of 8% per year, find how long it'll take until 20% of the population remains. Now, they're talking about decreasing, so that means decay. So you should remember that that means we're going to use y equals ab to the x. And if you remember, A represents your initial, B is your growth or decay factor, and T is time. Well, X is time, sorry. So basically we want to solve for how long it's going to take for that whole equation to equal 20% of the African lion population. Now, first off, I realize that I am decreasing. So that means that I'm going to take my rate and my B value, and I'm going to do 1 minus 0.08. Because in order to solve for the B value, remember it's 1 minus R if you're decreasing or decaying, and that's going to obtain your B value. So that means that I can replace B with 1 minus 0.08 to the X. Okay. Now, here's the deal. They do not tell you an A value at all. They don't say anything about the A value. They don't tell us what the African lion population is starting out as. All they say is that they want it to be 20% left over. Now, if you don't like that there's no A value there, let's just make up an A value. Let's say that you started out with 100 lions. Okay? And if you start out with 100 lions and you multiply this by 0.2, you will obtain a value of 20. So basically, if you want an A value of 100, that can pretend to be our initial population of African lions, you would set it equal to 20, because that's how much 20% would be left of. Now, here's the deal. Any initial value, even when you divide by 100, will get you back to 0.2. So all you really have to do here is set this whole entire thing equal to 0.2. Okay, now in order to solve this, I'm going to simplify the inside of my parentheses, and I'm going to get 0.92. And again, I want to solve for my variable, which is x, and it is in the exponent, so I need to utilize my rules of logs in order to bring it down. I'm going to use ln for this one. Again, you can use log if you prefer that. The x will come down, and you will now have ln of 0.2 equals x of ln 0.92. And to get x alone, divide by ln of 0.92. And when you divide that, you should get t to be approximately 19.3 years. And our variable is x, so I'm going to replace this with x. Okay, so this is your answer. So basically, if you chose any initial population, like say you chose 50 lions or say you chose 20 lions to start out with, even when you multiply by 0.2, you get a value. You're going to divide by that same initial value, and you'll still obtain a value of 0.2. So it doesn't really matter. The whole idea is that you're setting the equation equal to an equivalent 20%, which would be 0.2 in decimal form. So for this problem, I'd like you to pause the video and start to work on it. I'm say you're going to take you guys about 3 to 4 minutes to solve for this. I want you to try your best and solve for it on your own. So please pause the video, and then when you are done attempting to solve for the answer, resume the video and I will go through it with you. Okay, so I hope you paused the video and tried to attempt this on your own, but right now I'm going to go through it with you. In 2005, your great Aunt Sally retired after 40 years of service of the Wall Street firm and received a retirement bonus of $500,000. Because of the large sum, she was able to invest it at an annual rate of 7.25% compounded continuously. Right away, you should think about PERT, because you're compounding continuously, and PERT will allow you to solve for something that is compounded continuously. They even tell it to you. They say P is the initial investment, so that's what you start with, and R is your rate of investment, and T is your time. Now, your initial investment is her retirement bonus, because if you realize it says, because of her large sum, she was able to invest it. So she wanted to invest the bonus she received. So P is $500,000. My R is 0.0725 because I moved my decimal place over twice. And what I want to know is I want to know how long it's going to take to the nearest 10th of a year for my great aunt's money to double. And that means that my amount is going to become $1 million. So all I did here was I plugged in the $1 million for the A value. And now what I'm going to do is I'm going to solve for t. And the first thing I want to do is definitely isolate the base and the exponent. So I'm going to divide by 500,000. Now if you did this right, it should equal 2.0725t. This is a decimal value. Okay, so what you need to do now is get that exponent down. Now I notice I have e, and right away when you see e, you should think ln. And you're going to use ln on both sides of this in order to bring down the power. So my power is now going to come down. I have ln of e. ln of e becomes 1. That is why you want to use ln. And to solve for t, just divide by 0.0725. And you will get a t value of 9.6 years. So that is how long it's going to take approximately for her money to double. Okay, next question. So if you would like, pause the video and attempt this problem on your own. If you don't want to attempt it on your own, just continue it with me. So I'm going to start off with this problem right now. So this problem states when Patty was in kindergarten, her mother gave her 10 cents a week to spend. So this is her allowance. And in the first grade, she received 20 cents a week, double her kindergarten allowance. And in the third grade, Patty suggested to her mother that her allowance be doubled every year. Smart kid. But her mother was wise enough to refuse. So, if Patty's suggestion had been followed, what grade, so we're looking for the grade, would her weekly allowance be more than $200? That means that every week she would get $200. Now, they give you the formula. They give you a hint. Now, I wouldn't give you the formula. I think you guys can figure this out on your own. You're growing money, so you should have realized AB to the X was the formula that was being used. A is your initial. She started out with 0.10 cents. So you started out with 10 cents. And B is your growth or decay factor. And it's going to be 2 in this case because you're doubling your money. Anyways, so it says more than $200. That means you're going to set 0.10 2 to the x greater than $200. Again, what you want to do to solve for x, isolate the base and the exponent, so divide by 0.10. You'll get 2 to the x is greater than 2,000. You can use log or ln to bring down the exponent. I'm going to use ln. This guy will come down. X ln 2 is greater than ln of 2,000. Okay, to isolate the x, divide by ln of 2. Again, when you type this into your calculator, make sure you put parentheses around the ln of 2,000 and the ln of 2. So that means that x has to be greater than 10.97 years. Now, grades in this case is really what the exponent is. If you round down, you will not have more than $200. You'll be just short of that, actually half of that, so probably around 100. So to get 200, you're going to want to round up. So that means that x has to equal 11 in order to get her money to double. So that means that in 11th grade, her money would double. Well, double, it would become $200. All right, so I hope this video helped you understand this lesson. Tonight, your homework is to complete the review sheet for your quarterly on Thursday. And if you have time right now, definitely work on it with a partner or by yourself to get your homework started. I hope you had a good time watching the video. I'll see you tomorrow.